Okay, so the tests are almost graded. They will be up on Blackboard sometime today. So you can look at them, they're out of 50 points. I grade one problem at a time. In this class, I was getting a lot of minus zeros, so I think you did really well. My co-rec class, they took a lot of time grading. Anyway, so that will be up on Blackboard. I cannot turn them back till Friday because I have 2 athletes that are taking it Wednesday. What else? Project. The project is due this Sunday. The main post is due Sunday. Respond to classmates by Wednesday, so next week. Is there any questions on that? If you do not have a famous person yet, make sure you look under ones that are already taken and let me know. Any questions? Chapter 6. Chapter 6 is a lot of graphs and mean, median, mode, and range. And so on Friday, you will need to bring technology. Not that you can't work in groups, but you're each going to do it separately on your computer or whatever technology you want. I've had students use an iPhone before. It's not the easiest thing to download Excel and use it, but it works. You need to be able to have Excel on your computer, which is free through YSU if you don't have it yet. The steps are on Blackboard. If you have trouble, get to the IT center before Friday. Desmos. Desmos is very user friendly. You don't need to work. It'll come right up. So you need Excel and Desmos. Well, Desmos is just Google search. It's not a problem. But Excel before Friday's class. But don't wait till Friday because you know something's going to happen. Any questions on that? Okay. Chapters. To start with, there's some definitions that you need to know. And a lot of this is going to be your next project. You want to make sure you understand it. You're going to get qualitative data and quantitative data and do different graphs. I will open that up after. I might want to open it. There's a homework assignment on it. It's probably due this week. Let's look. I'll look when it's due. If it's due this week, I'll open the project up soon. But first definition you need to know is population. The pool of individuals from which a statistic sample is drawn for a study. So it's whatever group you have an interest in. Of course, if it's too large, you can't ask everybody. So then you need to narrow it down. So the population is the large portion. For instance, if we were taking a sample of people in the United States that have had COVID this year, well, we can't reach all of them. We take a group of them, maybe 100 from every state, some way to sample everybody. So one population could be American, another could be the world. Students at YSU, so it doesn't need to be huge. It could even go as small as this QR room. Now, of course, when it's small, I probably could do the whole sample. Grades on the exam, I can sample everybody but the 4 people. If you haven't taken the exam and you haven't reached out to me, you'll see a 0 there tonight. If you have a good reason, let me know. 4 people. But anyways, registered voters. So all of those are, examples of a population. We wanted to do a sample about sharks. There's no way we're gonna find all of the sharks. We're gonna take a group of them. Any questions on that? The group that we're taking is the sample. It's a subset of a larger population. So in this classroom, if the classroom was the population and I took the grades from 10 students, that would be my sample. When we're talking about a sample size, we use n for the sample size. So when you see it in certain formulas, n just means the size of the sample. Example, part of a population. Well, that's still the definition. The examples are after. So a sample is part of a population. 1,000 Americans, so n would be 1,000. Number of Americans, 340 million. A sample of 1,000, kind of small, but. Fifty students at YSU. 10 students in this class, so all of them are part of the samples that we said in the one before. Questions on sample? Part of your population. For the project, you will gather 25 pieces of data, so your sample will be 25. And there'll be two different groups, 25 that is numerical and 25 that is non-numerical. Questions on sample? Questions? I see a few people writing, so I don't want to go too far. Information being asked or measured. So when you have these 25 people that are in your sample, or 25, could even be an animal, that are in your sample, what are you asking them? What are you measuring? That's the data. Could be the grade on your exam, A, B, C, D, F. The number of pets a person owns. Or the kind of pet a person owns. Person's age. So when you're getting your sample, data is the information you're getting from each person or thing in that sample. Question. Frequency, the frequency is the number of times each of those answers. So like the A, B, C, D, the number of A's, the number of B's, the number of C's. So frequency is the number of times an event or observation comes up. There are 20 A's, 15 B's, 3 C's. Any questions? These are grades from the class I taught last, one of the classes I taught last. We'll work with ours on. Well, this one we've learned already. Mean or average. Remember, you add up all the data and divide by how many there are. Now, there's other ways of finding how data changes, and it's median and mode, which we'll be learning now in the next slide. Also the expected value. Used a lot in finance. Statistics uses it a lot. But mean is the same as average. Median and mode are not. In Excel, when you're using the formula, they use the word average instead of mean. You need to know. I forget now. They use one but not the other. So you need to know them interchangeably. The formula we've already had. Remember, the symbol means to add up the data, divide by how many there are. So if we have these numbers, go ahead and find the mean or average. Anyone want to say what they got? So when you add them all up, we got 33, I think. You add them up, you get 33 divided by, there's 6 of them, 33 divided by 6. The average or mean is 5.5. Any questions? Median. The M and the D, middle, the middle value. One of the 3 primary ways to find the average of statistical data. The median is the middle value, but you need to remember to put your numbers in order first. On a test, I know you know how to put numbers in order. I'm not going to leave them out of order. Too easy to make a mistake, because I know that's the first thing I would do is just go read the question and start finding it and not think about putting them in order. But do be careful that, I don't know, there might be one homework problem that's not in order. So the first thing, you put them in order. Second thing, if it's an odd number, so if there's an odd number of them, you just take the middle number. This first one, there's 7, so n would be 7. When it's odd, just use the middle value, which would be what? 8. So the median is 8. You're finding it, there's 7 of them. Subtract the 1 in the middle, and then divide by 2. There should be 3 on each side. 1, 2, 3, and that's my middle. So if you take your sample size and subtract 1 for the middle, divide that in half, and you should have that many on each side. That way then when it's large, what some students do is just start outside and keep moving in, and then. Any questions? The second one, what if you have an even number? If you have an even number, you take the 2 middle values. So since you don't have 1 right in the middle, you take the 2 that are in the middle, divide them, add them together and divide by 2. What you're doing is you're finding the middle of this. So 5 and 8 are my 2 middle ones. You want to find the number between them. You take your 2 middle values, 5 and 8, add them together and divide by 2. The median, 6.5. So you need to be careful when you're finding the middle value. Think about odd and even first, after you put them in order. And then odd, just take the middle, even, take the middle 2, add them, divide by 2. So 6.5 is halfway between 5 and 8. Mode, M-O, mode, most often. The one with the highest frequency. 3 different cases of mode. But mode is the most often for highest frequency. There could be only one that has the highest frequency, so then you only have one answer. So if we look at this one, there's 1, 1, there's 3 2s, 1 5. 8s and 9s do repeat, but they're only repeating twice. So 2 has the largest frequency. The mode is 2. But a mode could have one answer, no answers, or many answers. In this case, we had 1. So it's not that it repeats, it's that it repeats the most. If none of them repeat, then there's no mode. Now be careful, don't put the mode as 0 because 0 could be a number. So either put none or no mode, but don't use 0, it could be a number. And then more than 1 has the highest frequency. So if we look at this one, 2 is there 3 times, 8 is there 3 times, 9's only twice, the other 2 are once. So 2 and 8 have the same frequency and it is the highest frequency. So the mode is 2 and 8. So there could be, if the 5 was there 3 times, the 9 was 3 times, I mean, they could all have the highest frequency. So you could have more than one mode, 1 or. Any questions on that? Range. The range tells you the spread of data. So if I said the exam's out of 50, if I said the range was 20, that meant the grade spread by 20 points. So between the lowest value and the highest value, there were 20 points. To find it, oh, here it is. It's the largest value minus the smallest value. So what would the range be? 8. 9 minus 1 is 8. So range is largest minus smallest. Any questions on that? We'll do an example. Ask 20 homes in a neighborhood, the number of cars registered to their household. And we want to find range, mean, median, mode for the numbers below. There's an even number of homes, so I highlighted the two middle values, so it was easier for you to see with them on the board. So find the range, the mean, median, and mode. Which one range? Range is easy. What do we get for the range? 4. Because it's the largest minus the smallest, 4 minus 0 is 4. How about the mean? Add them all up.
1.65.
You add all of them up, you get 33, divided by how many there are, which is 20, you get 1.65. Median, I said it, are you getting 1.5? Take the two middle values because it's even. 1 plus 2 divided by 2 is 1.5. And what's the mode?
1.
1 is up there 6 times. The 2 was close, but there's only 5 of them. And everything else is less than that frequency, so it would be 1. Because 1 repeats the most. Any questions on that?
Are we ever going to do standard deviation in this class?
No.
Okay, good.
I don't know what it is. So she asked about standard deviation, which we will use for a normal curve, but we won't find it by hand at least. I'll show you how to find it on the computer. Because you take all your data, then you have to take the mean and subtract it from all of those. Then you need to square all of them. Then you need to add them all together. Then you divide them by n minus 1 and then take the square root of it. For this course, we don't. Even when I teach my stats class, I make them do it on a homework assignment 1 time. If you know, I mean, just 2 time continuing. All right. Let's try one more. We're going to add one more house with 2 cars. So now it's odd, and I highlighted the odd value in the middle. So there's 21 homes now. Did the range change? No, because we didn't change an end. If we added another house with 5, then it would have changed. So the range is still 4 minus 1, largest minus smallest. How about the mean? And what you could do when you're doing a problem and adding another piece of data to it, you don't have to re-add it. We knew it was 33. We added a house with 2 cars. So we added one more house, and we added 2 cars. You get 1.66666. When that line is over, it's just repeating that value. You could have put 1.7. Usually, the number of cars isn't part of a car. But when we're talking about averages, having a fractional amount is okay. But if you felt it needed to be a 2, as long as I don't say round 1 decimal place, then you can put mean. And what's the median?
2.
The middle value, 2. So when it's odd, it's the middle value. Is one still the only mode?
No.
No. Since we added a two, now there's 6 2s and there's 6 1s, so the mode is 1 and 2. Any questions on that? There's two types of data, qualitative. Sometimes it's referred to as categorical. I always say qualitative. The data can be arranged into categories based on physical traits, gender, color, or anything that does not associate itself with a number. So qualitative data is usually not a number. When you're getting data, if it doesn't have a number, it is automatically qualitative. There are few numbers that can be qualitative, but if it is not a number, it is definitely qualitative. Example, favorite color, type of car, anything that is not a number. Some cases where a number is qualified, it's qualitative. Something that is a number, but if you found an average or you tried to put it in an order, it wouldn't make sense. For instance, your phone number, if I put them in numerical order, it doesn't mean anything. Maybe area code would, but that would group you into categories. But putting them in numerical order wouldn't make sense. Adding them up and dividing by them wouldn't give you anything. And so they are qualitative. There's other examples, but most common, social security number, zip code, phone number. Those would be qualitative. I won't do that to you on an exam. I just wanted you, if you did research and look them up, zip code, well, that's a number, so it's got to be quantitative, but it's not. If you have to take the business stats class, then you would probably run into those examples. So qualitative, for the most part, is not a number. It's a quality. When you have qualitative data, you can find a mode. Find how many, the mode for the grades, A, B, C, D grades. The mode is probably an A in this class, because there are more A's than anything else. But you cannot, if you're using the letter grade, you cannot add them up. You can't find the middle. Well, as long as there's an odd number of them, you can find the middle. So for the most part, you can't find the median and you can't find the range, but you can find the mode. So qualitative data, not a number, you can find the mode, since you cannot find the other. The other type of data is quantitative data. Quantitative, quantity, it's a number. It has to be a number. Age, price of an item, age of a car, the number of pets that you own. When you have quantitative data, you can find all of the measurements that we talked about earlier. Mean, median, mode, and range, along with standard deviation. So quantitative data is a number. If it's not a number, then it's not quantitative. Any questions? There are two types of quantitative data. There is discrete, and you can count the number of people in this classroom. There are whole numbers or counting numbers. So discrete data is data you can count. The number of pets you have. You're not going to have part of a pet. Now, things that would have decimals or fractions, those are called continuous data. So if it could have a decimal or a fraction, then it's continuous. Age is one that could be continuous, depending on how you're taking the data. And if you ask for just the closest year, then you're making it discrete. But technically, unless it's your birthday, it's not on the whole year. So you could use decimals. You could be 19 and a half years old. You could be 19 years, 11 months. We could find fractions and decimals in there. Measuring your height, you're not just 5 foot or 6 foot, you have 5 foot, 5.5 feet. So that would make it continuous. If you're getting decimals and fractions possible, continuous. Usually continuous is measuring length, height, years. Oh, no, that's time would be the other one. That's time. Any value, all real numbers can have decimals and fractions. Discrete cannot have decimals or fractions. So for each one, I want to know if it's discrete or continuous. The number of students in class. Discrete, because we cannot have half of a student. Amount of time a student studies. Continuous. You could study for a half hour. You could study for 2 hours. You could study for 5 minutes. It's continuous because there can be decimals and fractions. The number of credits for a class.
Discrete.
Discrete. You either have 1 credit, 2 credits, 3 credits. They do not have a half a credit. So it is discrete. The number of registers at a checkout. Discrete. If you walk into Walmart, you can count the number of registers. In fact, they're even numbered 1, 2, 3, 4. They are counting numbers, therefore they are discrete. How about the time you spend in line at one of those registers? Spend a half hour, you could spend half a minute. But they are considered. Any questions on those? Okay. We look at this first. These are favorite color. There were 25 students. They were asked their favorite color, and the answers were red, blue, green, and yellow. And I just listed them here, but instead of writing the words, I used the letter. Is this qualitative or quantitative? Qualitative, does everyone? It is qualitative because they are not numbers. So for your project, well, you're not allowed to use favorite color, but if you did favorite color, that would be your qualitative data, and you need to gather 25 When you're making a frequency table, remember frequency is how many times it came up. So red frequency would be how many R's there are. So there's 10 that are red. Blue's frequency is how many blues there are, 3. Green is 7, and yellow. Oh, I didn't separate my bar graph. So this is our frequency, and there's 25 of them. To find your percent, you take how many there are divided by the total. So there were 10 red divided by a total of 25 people times 100. 40% chose red. Find how many, what percent chose blue. 3 divided by the total times 100. 12% chose blue. Green, 28%, yellow, 20%. And I added up the total. Now this is a bar graph. So that was just comfort. Anyway, to create a bar graph, the bars do not touch. A bar graph is for qualitative data. A histogram, which touches, is for quantitative data. So a bar graph does not touch. There's one thing called a prayer chart, but we're not going to get into that, where they do touch and you go highest to lowest. But a bar graph, they do not touch. And then you list each one. Now, I put this on the bottom. You could also go on the top and then your bars go sideways, which is also fine. But they still do not touch. Each one, red, goes up to 10 because there was 10 of them. Blue goes up to 3 because there was 3 of them. Green went up to 7 and yellow went up to 5. Any questions on that? If you're given it, I'm going to read them. So that uses your frequency. And I'm guessing this is probably going to do the same thing for my pie graph. But when you're doing a pie chart, instead of using the frequency, you're using the percent. Notice the 40% is the highest percent. It has the highest section. Now, it doesn't have to be exact when you're drawing it by hand, but don't make the 12% and the 40% the same size. Just show me that you know 40% should be the largest. And then I probably would do the 12% because it's almost half that between the two. And the other one is almost split. So I don't expect you to find the exact measurements. I just want you to know that you understand it's from the percents, and 40% should be much bigger than 10%. Any questions on that? On Friday, we'll learn how to make these from the data on Excel. Because for your project, you'll have to make a pie chart and a bar graph with qualitative data.
If it was an exam and we were asked to create a pie chart and we didn't use the percent, instead used the frequency, would we get that wrong?
I would only take a point off as long as the pie chart is correct, but yes.
Yeah.
Any other questions on that? Line graph. The line graph is used to show changes in time. Your time goes across the bottom. And then you go up and put a point above each one. So you'd have Friday on the bottom, you'd make a point at 70. Saturday, you'd make a point at 61. So there'd be a point at each one of these. And then you draw a line connecting the dots. The line graph is used over time. Any questions on that? 25 college students are asked their age. What type of data would that be? Qualitative or quantitative? Now, discrete or continuous, the way I have it written, it looks like discrete. If I asked that on it, I wouldn't ask that on a test because it could kind of go either way. If I did, then it would just be the way you explained it. You said the data is discrete because it's counting, there's no decimals and no fractions. Or if you say you could be 15 and a half years old, so you could have fractions, which makes it continuous. It's just in your explanation. This one, you could go even. I just didn't put decimals because it's more complicated than a small explanation or sample. So if we want to make a histogram, unlike a bar graph, histograms touch. The numbers go together because they're continuous, 17, 18, 19, 20. It's not a bar graph. To find what units you should count by, take your range and how many bars you want. So if we were going to draw this, the first thing I do is find my range. Remember, range is the largest one, 45 minus the smallest 17, which gets me 28. It's nice to have 5 to 10 bars. So I would pick a number that divides into the 28, which is 7. That's why I chose 7, because then I got a whole number. Now, in a class, maybe you have to make a histogram, and they want 8 bars. You divide by 8, and then if you have a decimal, you round up. Even if it's 4.0009, it goes to 5. So no matter what the decimal is, you round up. But I chose 7 because then it divided perfectly. Any questions on that part? So we count by 4s. You start with your smallest value, so we start with 17 and count by 4s. And then we stop when we get to the largest value. So notice on the bottom, I started with 17 and then I counted by 4s. 17 plus 4 is 21. Add another 4 to 25, add another 4 to 29. Now, the reason I went on, I'll explain in a minute. But at first, I stopped at 45 and then realized I needed to add one more. Any questions on the numbers on the bottom? Okay, now notice the first bar goes up to 14. The reason I got the 14, and I'll go back, but this first bar goes from 17 up to 21, but not including 21. 21 goes into the next bar. So 17 up to 20.99999. It goes from 17 up to, but not including 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14. There's 14 of them before the 21. And so that's why from 17 to 21, it goes up to 14. Now 21 is in the next bar. 21 up to, but not including 21. So anything from 21 up to, but not including 25. Here's the 25, we don't include it. We start with 24. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 values from 21 up to, but not including the 25. So 1 up to 8. And then we know there was a 25. And the next one was 32. So the 25 would be this one here. 32 is between 29 and 33. The next one, or the last one, was 45. So it could have been this far where I have it, or the one before. But we know each number goes to the bar on its right. So 45 would be the one here. If there was one person 49, then we need another bar. Any questions on that? So if you were just given this histogram, we know that there are no students at 33 years of age. If there was someone at 33, then we need another bar. Without looking at the data, we don't know what age this person is. We know they're 29, between 29 and up to 33, but we don't know what age unless you have the data also. So that would definitely be a question I would on an exam. For instance, how many students were of age 49? Well, there's no extra bar there, so none. But I couldn't ask you how many students were 19. We have no idea what these ages are unless we have all the data. It's the mode though. So the mode would be 17 to 21. Any questions on that? There's a way to find average. I don't get it. So a histogram touches. A stem and leaf. When you're creating a stem and leaf graph, the leaf is the rightmost data. So if we look at this, we have a tens and a ones position for all of them. There's nothing more or less. So the right would be the ones position, the left would be the tens position. The tens, we have tens, 20s, we don't have any 30s, and we have 2 in the 40s. And so when we write our left one, we have to go from 1 to 4. Even though there's none in the 30s, you still write it. So this is the tens position. 10s, 20s, 30s, we didn't have 30s, and that's why it's empty. Then we had a 40 and a 45. So it shows you how they're repeating. It shows you that there was more in the 10s than the 20s. These get lined up equally, but there were 2 17s and then 18s. Those will be all these 8s. And then there was 4 that were 19. So it's a way of shortening your data and gathering it. Again, it has to be quantitative to do that. We had a 20, a 21, 3 22, so on. There were none in the 30s, and then this is a 40 and a 40. And it's called a stem and leaf graph. This is the stem, these are the leaves. The leaves are your rightmost. So if we had 101, then this would have been a 1, and this would have to go all the way down to 10. Questions on that? I'm gonna stop there. We're gonna do a box and whisker next, but I'll stop there. Many questions. So make sure you look over your homework to see where you're gonna have questions, because we do have to finish the review first. And then we'll do whichever one gets questions. The attendance sheet is somewhere, make sure you find it.